Hello everybody and welcome back. We're on question 5 from our Euclid paper now. We've got an A part and a B part. So A, determine the two pairs, so they're telling us how many answers, two pairs of positive integers, A, B, with A less than B that satisfy the equation root A plus root B equals root 50. Oh, interesting. So root A plus root B equals root 50. What can we do here? We'll get ourselves a brand new sheet of paper first. But what can we do? Well, not a big fan of square root signs, so if we can avoid them, that would be fantastic. Let's square both sides. Okay. So we get a nice little something like this. So I know that square root of A times B needs to be an integer. When we do that, is there anything else we can learn from here? Not necessarily, but this isn't the only way we could do it. We could rearrange things and say root A is root 50 minus root B. Square both sides that way. And we'll get minus root 50B. But we can at least take out 50 is 25 times 2, so we could do something like that. And that tells me B, 2 times B must be a perfect square. Okay. So that tells me, B must be k squared divided by 2. So k needs to be an even square. Okay. What else can we learn from here? Oh, you know what? I'm going to keep doing this, but I think I just spied a shortcut to this question, but it's really an observation, more of a... I don't know what the best way to say this would be. It's really just sort of, if you see it, you're good. If you don't see it, you got to go the long way around. Anyway, so this tells me that B must be even as well. And through these sort of almost exact same sort of equations, you can see that A needs to be even as well. So B will be 2 times a square, maybe call it S squared. A will have to be 2 times a square in order for 2B and 2A to also be squares. Okay? And those two will sort of force this equation here to be satisfied. So we don't have to worry about that. But then, okay, well, there's only so many squares that we can deal with, and we know that A plus B have to be at most, in fact, they have to be strictly less than 50. So we can think about squares. Okay, and twice those squares, 18 and 32 and 50. Now 50's gone a little too far. Okay, but then I suppose we can start pairing them up. I suspect these two will have to be paired and these two will have to be paired, and that should do the job, shouldn't it? But let's double check. So 2 plus 2 times the square root of 2 times, what was it, 32? Plus 32. That's going to be 34 plus 2 times the square root of 64, so 34 plus 2 times 8, so that's 16, and yeah, that's 50. Okay. And then 8 plus 2 times the square root of 8 times 18 plus 18 will be 26 plus 2 times the square root of 8 times 18, which is going to be 144. And yeah, 26 plus 24 is 50. So those work out. So, okay, great. We've got it, and they tell me there's only 2 pairs, so I don't need to go hunting for anything else. 232, 818. Now, while I was doing the question, I realized there might be a slightly faster way if you see it. So root A plus root B is root 50. Well, root 50, if you take out the factor of 5, you just get 5 root 2. How can you possibly make 5 root 2? Well, you could take 1 root 2 and add on 4 root 2's. Or you could take 2 root 2's and add on 3 root 2's and square both of these, and you'll get the answers for A and B that we already got. So that's a much faster way to see it. Okay? But if you don't see it, then yeah, you sort of have to go this algebra route and say, well, you know, if k squared is even, then k has to be even. So k squared is really a multiple of 4. So you know, it's 4 times a square. So divide by 2, and then b has to be 2 times a square. You can do this sort of work, but you can see that did take me a little longer. Of 5 root 2 is 1 root 2 plus 4 root 2s. Okay? It's a light bulb question, so it didn't actually matter how we did it. All right, now we've got b, which we have to write up. Consider the system of equations c plus d is 2000 and c over d is k. Determine the number of integers k that are positive, well, non-negative, for which there is at least one pair of integers cd that is a solution to the system. Okay, so k is an integer. So since we can rewrite that second equation as c is k times d. This allows me to bring k into that first equation. 2000 is c plus d, but that's really kd plus d, and that's k plus 1 times d. Now we know that k is greater than or equal to 0, so k plus 1 is greater than or equal to 1, but now we've got factors of 2000. Now, do we want the actual values of k, or do we just want the number of k? So how do I figure out the number of positive integers of 2000? Because any of them will work. Well, there's a fantastic trick. If you write 2000 in terms of its prime factors, so it should have 1 2 to get me 1000, another 2 to get me down to 500, a couple more 2s will come out, 250, 125, and 125 is 5 cubed. So we've got 1, 2, 3, 4 2s, 5 to the 3. If I want to know the number of positive factors of a number, you write it with your prime factors. Take 4 here, 4 plus 1. Take 3 here and add 1. And you can do this with any of the exponents. You multiply them together, we get 5 times 4. There are 20 factors. So there are 20 such k plus 1. And since k just needs to be greater than or equal to 0, there are 20 such values of k. Okay? So not too bad a question, as long as we chose to rearrange. Now the reason I chose to rearrange this originally, I'm not a big fan of division. And with 2 unknowns, well technically 3 unknowns with that k, but 2 unknowns in our system, c and d, it makes sense to solve for one in terms of the other. And I say, you probably could have done this by turning it into c over 2000 minus c equals k, but eventually you're going to have to get down to this factors. K plus 1 is going to be a factor of 2000, just a question of how you manage to show that. Okay, so 20 possible values for k, and that's it. So we can move right along to question at number 6, but we'll look at that in the next video. Thank you guys so much for watching, and I'll see you next time. Take care.